The field winding used in this DC generator can be represented by a symbol. The symbol is that of an iron core inductor. Current to excite the field windings can be supplied from an external source. In that case, the generator is classified as separately excited. A small part of the generator's own output can also do the exciting. In that case, it will be a self-excited generator.
Hey everybody, self-excited generator. Okay, this is a very old video that's been released on the net. Electric Motors Part 1, DC Motors and Generators, 1961 US Army training film. Okay, I recommend for everybody that's learning this stuff, jump onto my channel and lots of other people's channels. There's lots of these videos around, and they are extremely interesting, extremely insightful information in some of these videos that you can't even find in some textbooks today. It's unbelievable the difference in education. 1961, 79 odd years ago, better back then than what it is today. Okay, so I strongly urge, go and, especially for those newcomers, especially for anyone that's wanting to learn, go and watch these videos until you know them off by heart. What we're looking at here is a self-excited generator. Okay, now you can see, and from the previous clip, this is just an inductor. This is an armature inductor. This is the rotor containing coils. Now obviously the coil on the rotor here opposes the inductor here. Okay, so this is self-excited. Now what do they say in the video? They say that the output of the generator excites this coil, so it's a self-excited generator. Now I've actually built a couple of these. I've built one machine that consisted of an electric motor. I think it was about a 1.4 horse or something like that, electric motor. I had a generator on it, a car alternator actually, and this was back in the days when I was investigating some of the early HHO stuff, the hydrogen and fuel cell stuff from the likes of Stanley Meyer and all that sort of stuff. Did a fair bit of work in that area. Now I built a machine that had the electric motor on it, had the alternator, car alternator on it, the same as what you can see in Stanley Meyer's videos. And I built the machine without any input at all except to the electric motor. So the electric motor spun up the alternator. The alternator had no input whatsoever except for the rotary motion, and I was able to get quite a large output on the alternator just by the very rotation of the alternator itself. Okay, so that was a self-excited alternator, just by the very spinning of the rotor itself. Okay, now how I did that, believe it or not, was I actually shorted the armature winding. Okay, so I didn't have the armature winding connected at all to the rotor. I actually brought it back on itself and shorted it. This was going back perhaps 10, maybe 15, possibly even 20 years ago now. So this was quite a while ago. It was one of those experiments that sticks in your mind, and you think to yourself, "Well, this is absolutely amazing. This is unbelievable. I've got rotary motion, yet I have a huge electrical output for no electrical input." Okay, very much the same as what a normal generator would normally do. Self-excited generator is perhaps not understood properly even to these days, because like I said, even just by shorting the armature winding here, even by shorting that winding, there is only very minute magnetic plus a rotary motion involved in generating the fields between the two coils. I didn't take enough video of it. I didn't document it enough. I was silly. I only have my own memories of it, but it was enough that stuck in my mind and played a pretty big part on my future endeavors. Okay, so if you want to try it, it will work. It's very, very, very simple. It's not hard at all. It does work. You can short the armature winding. Now you've got to think that the car alternator is a little bit different. The alternator has a rotor, has a field winding on the rotor coil, has brushes that come out on the rotor itself. The armature winding itself is actually on the inside of the rotor itself. Now I'll pause and we'll get a quick image of this so we can see what we're talking about. Okay, here we go. It's probably not the best image, but it's a pretty good one, this, thanks to Drive Smart. So the shaft here, you can see this is the rotor here. Okay, there's an armature or a stator winding over here. Okay, armature and stator, same thing. The rotor itself has a coil in here on the inside, and that's the field coil. The field coil comes across into these, you could almost call them teeth. Okay, and then there's a magnetic field that traverses between these gaps here, okay, from each side here. Okay, so one being a north pole obviously on one side of the coil, one being a south pole on the other side of the coil. So where we're going to find the strongest magnetic field will be on the ends. In the middle, it should be reasonably uniform, but probably on the ends will be the most, the strongest. Okay, so we have a sort of a half circle magnetic field which goes from pole to pole all the way across these gaps here, okay, and then all the way back up on this side because it does it both sides. Now you can't see, but in behind here where the voltage regulator says, the rotor itself has a couple of bearings, a couple of brushes I should say. Now the brushes come out to what would normally be input from a battery or something like that. So a battery would create this field coil here to be energized, and this is the coil that I short circuited. So all you need to do is just short circuit that coil, and then the rotary motion itself of the generator will generate in the stator windings, in the armature windings, a goodly EMF. Now obviously, again, this is, and we all know Faraday's law of induction off by heart by now, but the rotation speed versus the magnetic field itself changing in proximity to turns N is the EMF. Okay, so it's negative. So there is a torque, if you like, that is exerted on the shaft itself. Okay, and that will always be there. We can't expect that to go, because as soon as current starts traversing these windings in the stator or armature, it is Newton's third law. It's action, reaction, pairs start occurring. So as soon as the action of this magnetic field over here changing in time generates an EMF. EMF is a voltage. Okay, EMF is measured in units of volts, and then when that EMF is loaded, then an MMF occurs because of the current, the change in current as the voltage starts changing. Okay, now it's not the voltage itself that causes the torque. Okay, we explained this in the last video. What causes the torque is the current. Okay, current being the back EMF. Okay, back EMF, because this is in reverse. The stator current is in reverse to the changing magnetic field on the rotor. Alright, we've been through that again in the last video. I just want to make this perfectly clear to people. So there is a torque on the rotor. Okay, so the torque, as we explained in the last video, is equal and opposite less losses. Okay, now if it was perfectly equal, we find we get to a point one day where we could no longer turn the rotor. The rotor itself would stall because of the forces, okay, and you wouldn't be able to turn the rotor anymore. you've got to remember it's equal and opposite less losses, and the losses themselves, that's why the force, the torque, if you like, on the shaft must always increase as the load increases. Same with a transformer, same with a generator, they're all the same. So our self-excited generator here, perhaps I gave you the wrong impression before. By shorting this coil over here, you probably could do the same thing. I mean, I think it could be reversed back the other way anyway. But the stator coil, or rotor or armature coil, I should say, over here is designed to carry large currents. I think most car alternators are rated around about 70 sort of amperes, some of them a little bit higher. At, I forget exactly, I think it's something like about 30 volts or something, I think, from memory, and it's regulated. I can't quite remember exactly, but anyway, the point of this video is self-excitation. Okay, you've got to remember that any changing magnetic field in the proximity of another conductor, if this magnetic field over here is changing in time, this one over here must also change in time, as long as it's loaded. Okay, and a short circuit is a load. Okay, it doesn't matter whether you short circuit, load it, whatever it is, it's going to carry a current. It's got to have a current to have a magnetic field. And remember, the magnetic field itself is an MMF, a magnum motive force, and it's the magnum motive force that is the work component. And EMF, being a voltage, is not work. Okay, voltage in science is considered free. It doesn't take work to create voltage, or at least that's what science will tell you. Now, a voltage can be created only several different ways. Okay, human beings, as we currently know science, can only create voltage a couple of different ways. Changing magnetic field is one of them. Chemical reaction is another. Okay, things like a battery or a solar cell or something like that. And to be honest, I can't even think of anything else off the top of my head. I'm sure there's one or two others as well, but a voltage can only be created by a couple of different things. There's only 2 or 3 different things in science, and a changing magnetic field is one of them. It's very, very important. Okay. So the voltage comes first, and as we load the coil, then the current comes second. Okay, so like I said, this is an action-reaction pair. Equal and opposite, less losses, action-reaction pair. Newton's law. Okay, drop the apple, what happens to the apple? The apple drops to the ground. Okay, so for every force there's an equal and opposite reaction. For every action there's an equal and opposite reaction. Newton's laws. Newton was pretty much a giant when it came to physics, science, all that sort of thing. Really, Newton, to be honest, was probably one of the first, perhaps the father or even godfather of science. Now, Newton's laws are pretty much universal everywhere you go, and the definitions perhaps might change depending on where you go. Newton had 3 laws, as far as I know. Now, I actually have on my website that the 3rd law was excluded, but apparently my information is correct, and apparently it was changed rather than excluded. So Newton has 3 laws of motion, and really everybody knows about the you know, for every action there's an equal and opposite reaction. Okay, rocket science is perhaps one of the best places to think about this, and that's why I've got this image up. Rocket science, we all know how much a rocket weighs. You know, sometimes it can be hundreds of tons, and we all know that we've got to have a huge amount of rocket engines and fuel and all that sort of thing to power them to get the smallest of weights up into orbit. So first law, you can go through if you want to and have a bit of a look at that. Okay, that's the first law. There's Newton's second law. Okay, remembering force equals F. M, small m normally is mass, A is acceleration. So force equals mass times acceleration. Okay, now there's a third law, and unfortunately I couldn't find NASA's imagery there. So we'll go back to what I can find, just a minute, and here's the third law. Okay, so the weight of the rocket itself, okay, has a gravity, okay, and the gravity is a downward motion. Okay, we have a force being the rocket thrust, which can be millions and millions of pounds sometimes. So a huge amount of rocket thrust in one direction to force the rocket go in another direction. And now magnetic fields are the same thing, exactly the same thing. Okay, we're going to find these arrows, whether they be pointed together or pointed apart like this, we're going to find it everywhere. It is the same thing. Force equals mass times acceleration, which has an equal and opposite force expressed. Okay, and here for every action force there is an equal and opposite reaction force. Okay, I was told some time back that there is an extension to this, and I believe there is. From all my work, there is an extension, and the extension that I've come up with is for every action there's a reaction, and for every reaction there's a counter reaction. Okay, so the action is always the first one, the reaction is always the second one, and we can have a third reaction or counter reaction which counters the reaction but assists the action. And this is what everybody seems to be missing. We seem to be missing the most basic fundamental ideas in science, which is for every action there's a reaction, but we seem to completely forget about the reaction. Why don't we use part of that reaction back on itself? Okay, so if we were firing all this stuff out the back here to try and lift the rocket up, you know, a good example of that is the scramjet. The scramjet uses as much input force as what there is output force, plus a little bit more. Okay, we'll actually see if we can find an image. Okay, so scramjet. Now most jets work on this similar sort of principle. Some of them have great big fans up here that blow the cold air in, heat the air up, and as the air is heated out the back it becomes an exhaust, which is, because it's superheated, has a much greater extrusion rather than intrusion. Now obviously with any sort of jet, the input oxygen is being fed in and used. So in the burning process, the oxygen that's supplied to the jet is the intake. Now with any fire, most everybody knows that any fire needs oxygen, and to put a fire out you just smother it to stop the oxygen. Now, I mean, most people would never believe you if you were to say that oxygen is one of the most deadly gases known to humankind. Well, it is actually, to be honest. Oxygen is extremely dangerous, especially if it's in large amounts. We breathe it, but no one would believe you if you told them that. Anyway, the idea here is that it sucks in just as much atmosphere, if you like. It sucks in the atmosphere, and when it's burnt it expands, and as it expands it gets pushed out the back at a much higher velocity. And this is the way the scramjet works. This is the way most jets work, and they all are a little bit different. But the fuel ignites the oxygen. Okay, well the fuel, at least the fuel and oxygen mix is ignited, I should say, is a better way to say it. And when it's ignited, as the air is superheated, it expands, and as I say, it's pushed out the back as an exhaust, if you like. So what this is doing is this is using as much input as it is output, but the output here is much greater because it's ignited. Okay, so as is ignited, it expands, as I say, and as it expands, it comes out the back with much greater velocity. Okay, so the greater the velocity here, again, force equals mass times acceleration, the mass being the size, the mass, the weight of the scramjet, acceleration being the force in this direction, so out the back, and obviously this point over here indicating the direction that the scramjet will go, out the front. Okay, so we have equal and opposite arrows. and the center bit here, you could even say, okay, the sharp bit over here is indicating an arrow out that way. The sharp bit over here is indicating the travel of movement over this way. Okay, so equal and opposite, even though it looks like anything that's coming in the front is assisting what's coming out the back, and it is, that's exactly what it's doing, but we're forgetting that the mass of the scramjet itself is being accelerated forward by this process over here. So again, we have our equal and opposite arrows. Okay, it's a fundamental fact throughout science. It cannot be disputed. It cannot be anything. It's there, and we've got to abide by the fundamental, basic, most elementary rules of science. It's there. It's always going to be there. It will be there until the day that we die, and there's no getting around it. The best we do is try and use something like this, something like the scramjet, okay, so that we have something to assist the operation, okay, of the arrows, one going this way, one going that way, okay. So this input air velocity as the scramjet moves forward assists in the output velocity over here. Okay, so this output velocity here, we could use two tanks like a normal space rocket does. LOX, liquid oxygen, in one tank, something like ethanol or something in another tank. Mix the two together, pump them through to the jet engines or to the rocket engines, and in that way you can have a rocket that will perform in space. Obviously there's no air in space, so you can't use a scramjet in space. It's only good within Earth's atmosphere, and that's why we do it like that. So again, we've got to stick to the fundamental rules. Magnetics is the same. We have equal and opposite. There's always equal and opposite. Okay, it will be equal and opposite till the day we die. I propose to you that this action does not have to be something that we have to input to the system. Okay, by turning the rotor here, the rotor generates a voltage, and this is depicting a voltage. So they do actually say in the video it's self-excited. So what they're actually saying is that the rotor here, the spinning of the rotor will actually power the armature coil, and they actually say that a little bit of the generator's output is fed back to power this coil, and as I've just stated, you can short circuit one of these coils and you can still make it work just by simply spinning the rotor. Now there might be just a ever so slightly residual magnetic field in here, perhaps even a magnetic field that's even so small that it may not even be detectable, but there might just be just a residual magnetic field, and the actual turning of that actually increases this effect overall. They do say that in the video that you'd need to magnetize one of these coils, but I've not found that you need to do that. It's not something that you always have to do. In some generators you may have to, but not always. So in this video they go through and talk about the generation of EMF. Highly recommend watching it. This is a very good video. It's highly educational. If you want to learn about generators, motors, all that sort of thing, highly recommend going and watch this video. I'll link it in the description. And the point of me doing this video is to show you that this, it's a bit hard to explain, but the self-excitation is extremely possible. Okay, now there's another type of excitation that they go through and explain as well. We'll just play a little bit more and we'll just sort of see if we can get to it quickly.
Generators must be initially magnetized. The residual magnetism in the core of a field winding provides enough magnetism to begin generator action. The field coil winding may be connected in several ways. This is a series wound generator, which means the field coil is in series with the armature. Because of this series arrangement, it has poor voltage regulation.
An interesting concept. They say straight up, series wound has poor voltage regulation. And why does it have poor voltage regulation? Well, the spinning of the spinning of the rotor here versus the armature coil, and then the load, and then over here a switch to control the load. Okay, so for example, the switch might be tripped if this load over here goes over voltage, or something along those lines. It's a pretty interesting concept when you think about it. First of all, why is the voltage hard to control? You've got to sort of start asking these questions. Why is the voltage hard to control? First of all, any magnetic field as it builds up must always collapse. Okay, so there's an increase of magnetic field, and then there's the inductive collapse, is what I call it. And we're all familiar with that through John Bedini's SG and all that sort of thing. Okay, so all of us that have done that work, the inductive collapse is what we catch on the other side of the coil with a diode and all that sort of thing. So voltage spikes are very, very damaging to a lot of equipment, and that's probably what they're sort of talking about. They're probably talking about the voltage collapse and all that sort of thing. Now, as the rotor turns, this is something that is forgotten a lot of the time. As the rotor turns, the rotor's magnetic field must always oppose. Okay, if it doesn't oppose, you can't generate energy. I've had this discussion with a few people. Energy comes from, voltage at least comes from the change in magnetic field. Okay, and then current is the opposition of magnetic fields. Okay. Current must come from opposing forces. Okay, opposing magnetic fields, opposing MMFs, frees more electrons from the copper atom, and it pushes them down the wire. Okay, if you don't have magnetic field opposition, then you cannot pump current. Okay, this is a fundamental concept, something that everybody before us has been through. Andrei Malenchenko, Tariel Kapanazi even said the same thing. All you need to do is look at the way their coils are wound. Okay, you have a certain portion wound clockwise, a certain portion counterclockwise. Okay, the very fact that the coils are wound that way, and essentially being the same piece of wire, means that the coils must oppose each other, at least for a portion of the resonance cycle. So anytime that coil carries current, part of the coil opposes the other part of the coil. Okay, it's a fundamental fact. You must have opposition. Okay, whether it be transformer, you have a primary, the primary is opposed by the secondary. Okay, or a primary which is opposed by the secondary. It's always fundamental fact. It cannot be avoided. It's always true in every circumstance, every situation. Now there are, for a few of you that might be watching, there are other alternatives where the knee of the BH curve, those of you that are following will understand what I'm saying. The knee of the BH curve can be used in some situations, I believe, to give a core to coil opposition. I believe that can be done, but I believe it's very limited in what you can do with it. So somewhere, somehow, there must be an opposition, otherwise you'll get voltage but almost no current. It's like, for example, you have a transformer, a DC transformer. Okay, DC transformer, you switch it on, you start conducting through your secondary coil. You switch your primary off. What happens as soon as you switch your primary off, your secondary switches off as well. Okay, they oppose. You switch your primary off, and your secondary switches off as well. So it's really, really important. Okay, there's always got to be opposition. So the change in magnetic field, and you can see that on the current curve in a coil. Okay, if you were to pulse a coil with a DC and you monitor the current, you can see an exponential curve in the current. So the changing current will create a voltage. Okay, and you can see the voltage stops changing when the current curve stops changing. Okay, it's experimentally, I can prove it. I've proven it in some of my videos previously. So I urge everybody, go back and have a look, because some of the videos, some of my previous videos, doesn't only cover working machines, but it covers how to get there as well. Okay, some of my series that I've just recently released gives you everything. Okay, you don't need to keep watching these videos. If you want to go and learn that, go and watch some of my previous videos and you'll learn how to do it. Okay, like I say, there must always be an equal and opposite. Okay, if you have additional magnetic fields, so say for example this armature coil here and this rotor coil over here, if they were additional, so they weren't opposing, that they were, what's the opposite of opposing? In addition. So if they were adding together, then current still couldn't flow. Okay, Lenz's law predicts the negative of the current. There's only one method that I know of that you can change Lenz's law, and that's by the Mr. Prever experiment. You can pump current the opposite direction, but it kills your voltage. Okay, so as soon as you start doing that, you lose all your voltage by doing that. And this is something that we've proven time and time again, and it's something that you can prove in the Terrell Caponese device as well. So if you have turns that are equal and opposite, they're laid on top of each other, and I've shown it in some of my videos as well, and I've asked the question, why does it do that? Why do you lose so much voltage, all that sort of thing? Well, that's why, okay? So there's various different methods you can do, but to get voltage, to get current, okay, you've got to follow those couple of rules. So the first rule is you've got to have a change in magnetic field to get a voltage. Second rule is you've got to have an opposition of magnetic fields to pump current. Okay, those two rules are critical and will stand throughout time no matter what. Doesn't matter what anyone says, doesn't matter what experiments come forward, the same will be proven time and time again throughout history with conventional coils as we know them. Now, I'm not saying conventional science is absolutely right. A good portion of it is mostly right, but there's a lot of assumptions. Okay, so there's two different things we're talking about. Alright, let's move on for a little bit.
Additional load will cause more current to flow in the field coil. Increase in field strength increases voltage. Increase in voltage causes more current to flow. This continuing action stops only when the core is saturated.
Okay, and that's true. You've got to remember Ohm's law. Okay, so as the voltage goes up, the current must also go up. What is the old equation? The old Ohm's law equation. Current I equals voltage over resistance. So the resistance might stay the same, but as the voltage increases, as will the current. Okay, so that's true. We know that to be true.
When the load is increased, the voltage will increase. When the load decreases, voltage will decrease. Voltage regulation in the series wound generator, therefore, is very poor. When instead of in series, the field winding is connected in parallel with the armature and the load, we have a shunt wound generator. Now the field current is independent of the load current. Therefore, an increase in armature current will not cause an increase in the voltage output. Voltage regulation here is greatly improved.
So why is voltage improved here? Why have we improved the voltage? Again, the rotor coil must always oppose the armature coil magnetically. Okay, so being that they are series wound, this is a little bit of a different story. Shunt wound, if you want. Shunt wound means that the magnetic field on this coil is regulated again by the magnetic field on this coil. Again, they must oppose, but there is a regulation here. Okay, so we have essentially continuous rotation here. If the rotation is stopped, then each of these coils will try and power each other. Okay, so as this one decreases, then this one must decrease. You'll find that they decrease linearly over time. So if we were spinning this up, and we had a load on it, then instantly the rotor stopped. Then we get a linear decrease over time of voltage and current as the magnetic fields themselves decay over time. They would decay over time slowly because obviously they oppose each other, but the potential over here will also it won't diminish instantly. Okay, so there'll be a linear decrease over time. Look, I really want to say these videos are super important. You can take little bits out of these videos that will advance you in your work beyond what you currently think. These old videos have so much information in them. Okay, I want to wrap this video up with this image. Now, you're going to find partnered output coils everywhere. Partnered output coils is the only way that I know of to create excess energy. Well, we're not actually creating it, we're pumping it from source, the source being the copper atoms within the copper wire, which is exactly the same as what the standard generator has done ever since it was its inception well over 100 years ago. Everybody, the partnered output coil, the arrows that you see there are magnetic fields opposing themselves. They oppose at different stages through time. Okay, so for example, and what I mean by that is that the magnitude of the magnetic field must change in time to make this work. We have magnetic fields that modulate, and remember that Floyd Sweet, and this is Floyd Sweet's VTA as you can see there, Floyd Sweet named his original device the Space Quantum Modulator, or Space Flux Alternator was the one that preceded it, and that was the rotary version. And Floyd stated specifically that the ideas, the concepts were the same. The documents are all up on my website if you want to go and read them. They're extremely simple to read, but you've got to read them with a great deal of attention and pay attention to every single fact, because sometimes some of it is extremely easy to go over and not really understand it. The Mr. Prever experiment is a byproduct, if you like, of these ideas. Okay, and a lot can be learnt from the Mr. Prever experiment. But as I've pointed out in other videos, if you were to consider the arrows as current, okay, we've got current moving up through this coil, across it, down into this coil, and out over this terminal over here. Okay, now that means that we've got, if we follow this up, we've got current that moves down, out through this terminal over here. So the current coming back from this terminal, if we follow, goes up through this coil, and that means that these two coils oppose each other. Okay, up over here, down, that means these two coils oppose each other, and then out through over here. So at any one point in time, these two coils here, these two coils here oppose each other. Okay, in the Nothing is Something paper, Floyd Sweet tells us exactly the same thing. Okay, if we scroll down to the part where he talks about, okay, here, is that all in? It looks pretty good. Okay, the principle of superposition. Superposition is where you have two, normally is electromagnetic waves in space. Okay, when you have two electromagnetic waves in space, their vectors, the magnetic field vector or the electric field vector, is considered the field of working on those vectors is considered superposition. So normally this would be cancellation. So if you had cancellation of two magnetic fields, which Floyd Sweet talks about to double the current, then that would be superposition. Okay, on this, it's probably worth even looking up very quickly. So if the directions of the two signals, this is superposition, remember, so if the direction of the two signals are such that opposite H fields cancel and E fields add, an apparently steady E field will be created. The energy density of the fields remain as calculated above, but the value of the E field will double from E over 2 to E. Okay, so that's what I'm sort of talking about when it comes to superposition. Floyd Sweet states this empirically. Okay, now this is the bit on superposition again. The principle of superposition states that in order to calculate the resultant intensity of superimposed fields, each field must be dealt with individually, as though the other were not present. Okay, this bit's really important. Okay, because he's basically telling us here what the whole thing is doing. Field, he's talking about the magnetic field, where the magnetic fields are going. You've got to ignore one to deal with the other. Okay, the resultant is obtained by vector addition of each field considered singly. Okay, basically just stating the same thing again. Consider for a moment the construction of the triode. Okay, again, very important statement, which includes the bifilar coils located within the fields of the two conditioned magnets. Conditioned magnets is rubbish. Okay, it's complete load of hogwash. We're talking about the coils magnetic fields alone. Okay, when the current in one half of the conductors in the coils. Okay, so we're talking about, what are we talking about? The coils in one half of the conductors. Okay, remember the diagram, i.e. one of the bifilar elements in the device is moving up. Okay, we saw the arrows before. Both the current and the magnetic field follow the right-hand grip rule. The right-hand grip rule, look it up if you don't know it. Very important rule, you need to know it. The resultant motional E field would be vertical. What's vertical? We have our excitation coils vertical, wouldn't it? Okay, both inwardly directed. So the resultant motional E field would be vertical to both and inwardly directed. Now we're talking about, at this stage, we're talking about inwardly directed several times. Okay. At the same time, the current in the other half of the conductors in the coils is moving down. Both the current and the magnetic field follow the right-hand rule. Thus the motional E field again is vertical to both and inwardly directed. Okay, we've got arrows again, both inwardly directed, so they're opposing each other. Thus the resultant field intensity is double the intensity. Okay, what did we say before? Double the intensity. So this is the resultant field is double the intensity. What's double the intensity? Is E over 2 to E, isn't it? Attribute to either one of the set of the coil conductors taken singularly, expressed as E. So there, E being the electric field, equals B times V plus negative B times V equals 2 B times V. Why is it 2 times B times V? Because we've got two conductors that oppose each other. So B, the superposition of B is equal and opposite, which gives us E and not E over 2. There's the 2 there. So we've got 2 BXV, which gives us E. Okay, I think everybody, I think it's really important that we study this, make sense of it. Okay, this video shows you empirically how important this is. Go read the documents, because this here is super important. Very, very important stuff here. If you understand this, you understand the basics of, first of all, generating voltage, supporting a current, powering machines that have very, very, very little input for large amounts of output. Extremely important. I really hope people pay attention. FB is short for feedback. Okay, these are the feedback coils. These are the excitation coils. We've just learned what excitation is. Excitation excites the feedback coils. The feedback coils get these coils moving, opposing. So one you could imagine as the stator, one you could imagine as the rotor in the diagram at the start of this video. Okay, we've got two. Okay, now on that, these coils, the cross-sectional area of these, if you visit the website, you'll notice that the cross-sectional area has been measured to be correct for the turns that are involved here. So Floyd Sweet wanted 120 volts at 60 Hertz. These coils at 240 turns each, for the cross-sectional area that they were correct for the turns, correct for the cross-sectional area for 120 volts, well within the change of flux that was expected for these particular coils. Okay, so what you could say here is these two coils are the equal and opposite. Okay, this is Newton's equal and opposite law. So one that way, one that way, equal and opposite. Feedback coil here, you could say that that's the air intake to the scramjet. Okay, all we're doing is this is the rotational speed, if you like, not the torque, the rotational speed on the rotor. We don't need torque because the torque is here. Okay, the torque is between these two coils. Okay, the torque that is considered the generation, or the force, if you like, the force to generate the electricity, is between your partnered output coils. Okay, there's two here because this was referred to by Floyd Sweet as an oscillator. Okay, I can bring that up very quickly. Okay, this is Floyd Sweet's lab notes. This was well before Tom Bearden came on the scene, and you can see here oscillator, generator. Okay, so gen is the VTA. Okay, and these are all the meters that are involved. Now if we scroll through a little bit more, Floyd Sweet refers to it as an oscillator. Here we go here. Now it's possible that this was just a mistake, a handwritten mistake, but he's got oscillator here and then he's got oscillator here again. This oscillator here is the VTA. Okay, it is an oscillator. It's a magnetic pump, if you like, a magnetic charge pump, an oscillator. So again, if you were to apply the ideas Floyd Sweet gave us as much as we could possibly need. It's a real shame that some of it was twisted out of proportion, but this is an oscillator. Okay, from one side to the other side it's an oscillator. It builds up tension in the coils. As the tension builds up, thanks very much to our feedback coils, our excitation coils see the change. Now you've got to remember that when two magnetic fields opposed together, there's an extrusion of magnetic field out through the excitation coils, and see, even these arrows oppose each other. Now I've got to be honest, okay, I'm going to be straight up and honest, I'm not anywhere near the Floyd Sweet level. Okay, I've built some machines that show some pretty exciting results, but I'm not at Floyd Sweet level yet. Okay, I think I understand a great deal of what Floyd Sweet was doing, but there's still some stuff that I'm not at his level yet. Okay, so I want to finish this video up with that. I want everybody to start thinking along the lines of, or at least those people that are interested. Those people that are interested, I want to get them to sort of think along the lines of changing magnetic fields, what they can do, you know, what they do in a generator, how the generator pumps charge. Okay, look at the old videos because there's a ton of information in there. Learn what Floyd Sweet knew. Okay, Floyd Sweet worked for General Motors, I think it was, or GE it was, General Electric, sorry. He was a genius. He had decades and decades and decades of experience under his belt, and I've heard some other pretty amazing things as well, which I can't really repeat because I can't verify that. But some of it sort of it says to me that he was very, very, very skilled in what he was doing. Okay, we can get there, but it's going to take time. It's going to take all of us working together. So again, think about the magnetic fields, what they do together. The arrows, okay, arrows are important. They've always got to oppose each other, okay. Floyd Sweet even said similar things, you know, sort of basically told us in some of the documents about, you know, accelerating charge and all that sort of thing. So go read the documents, tons of information there. Look at all the old videos, there's tons of information there, and look, it's perfectly possible. You can build these machines. Come to our forum, learn how to do it. We've got basic machines running, we know what we're doing. Come and learn from us. Thank you.